All right, folks, we are going to take a look at 2018 FRQ number 3, which is a probability question. And it's going to be a probability question that gives us a couple different things we need to talk about. All right, so we got 3.5% of all children born in a certain region are from multiple births, so there's twins, triplets, etc. Of the children born in the region who are from multiple births, 22% are left-handed. Of the children born in the region who are not from multiple births, 11% are left-handed. So first question is, what is the probability that a randomly selected child born in this region is left-handed? So a couple things. Let's start with notation. So we have the probability of being a multiple birth. So I'm going to be writing these all as proportions, not percents. So just a heads up, it's really important. And it says, of the children who are multiple births, so given that somebody is a multiple birth, the chance of being left-handed if you are multiple births, the chance is pretty high. Also left-handed, but not multiple birth. So then the other option here is the chance of being single birth, left-handed, given that you're a single birth child, that you're not one of those guys, is 11. And then the chance of being from a single birth is not being a multiple birth. Just a heads up, 1 minus probably being a multiple birth. These are complements, they're opposites. They have to add up to 1. So that's going to be 1 minus 0.035, so 0.965. So I am one of the 96.5% of people who are not a twin or triplet, as are many of you, and some of you are over here. Okay. So that's the info that we've got, just so we're clear about the notation. So what's the probability that a randomly selected child is born is in the region is left-handed? We're going to have to figure out the combo of sort of in the population, how many people are multiple birth and left-handed, how many people are left-handed and single birth, and how does that balance out? So one of my favorite ways to do this is to use a tree diagram. This might not be the best way to do it on FRQ during the AP test, but just as a way to understand what's going on here. So tree diagram, you split into two or three or however many events that are absolutely not going to overlap. So these have to be mutually exclusive events, and we have to add up to 1. So we're going to start with single births, multiple births. You can't be both. Okay, so we got this probability. I like putting the probabilities on the tree splits. So 0.965 over here, 0.035. So these guys should most definitely be adding up to 1. And then we're going to split into left-handed and not. Okay. So we're not focusing on the other variable here. So the chance of being left-handed if you're a single birth, that's how I got on this part of the branch. And chance of being left-handed if you're multiple birth. Now, ideally, I tend to like to really lay out the whole tree and fill all the numbers in, but just for expediency, I'm going to not do that. But if you needed this number, this is going to be 1 minus that one. So 89% of people are not left-handed in single birth. And this will be 78% of people down here. So heads up, guys, this is a sample space. It's organizing everything that's going on. However, to finish your tree diagram and get the stuff you really need, you are going to have to multiply along the branches to get your combo event. So what this is going to be is the probability of being a single birth and being left-handed, both being true for one human. And you're going to be multiplying the probabilities as you go. Okay. You would do the same down here. I'm just going to not do that. So this will probably be multiple births and left-handed. That's going to be 0.035 times 0.22. So the reason we're doing this is to figure out how these two numbers balance out in the population of left-handed people. Because obviously multiple birth folks are more likely to be left-handed, but there's just fewer of them. So we want to see how that works. So this number is telling me that 10% of the population is left-handed in single birth. That's what that's saying. And then if we try the other one, as you can see, this number's going to be quite small. So slightly less than 1% of the population is multiple birth and left-handed, even though much more likely to be left-handed, right? And then we're going to add these up because we want to know the chance of being left-handed. There's 2 ways of being left-handed, being single birth and left-handed or being multiple birth and left-handed. These are complements. There's no other way to do that. So the probability of being left-handed is going to be these guys added up. Okay. And the reason I want to see that, so now I've got everything laid out, I can see how it fits together, it makes sense to me, I get some intuition about what's up. So the question is, what is the probability that a randomly selected child is left-handed? So the chance of being left-handed is, oh, I got it. Okay. This is really just a starting step. So a lot of probability questions are going to set you up for something you need later. So I think that's what this is about. Right. So second question, what's the probability that a randomly selected child born in the region is a child from a multiple birth, given that they're left-handed, right? So of these 11%, we're ignoring everybody else. We need to fill them in. For these 11% of people, what percent of them are multiple births? So it should be a higher proportion than it is in the population. So it's going to be higher than 3%. And another way to think about this is to add a Venn diagram just for informational purposes here. So we have a Venn diagram. Venn diagrams are super different from tree diagrams in terms of what they can display. So let's say being multiple birth is here and being left-handed is here, and we have this overlap, right? So we're kind of focusing on, if I know someone's left-handed, I'm ignoring people who are not left-handed. So I'm in the black circle. What's the chance? What proportion of left-handed people are multiple birth? Right? That's the question. So the way to answer this, you kind of get your numbers from either place. So we're saying, what's the chance that someone is multiple births given that they're left-handed? Now notice, this is different than what we had up here. It got flipped, right? Now there's a really easy trick for doing that. I'll show you that as well. But given sort of tree diagram layout, let's talk about this. On the sheet gives us something. It gives us this conditional probability formula. So what's the chance of being multiple births given that you're left-handed? It's going to be the chance of being multiple birth and left-handed divided by the chance of being left-handed. So we're going to write that out. That's something to keep in mind. But what I'm going to do is just focus on what we got here. So we have two groups of people who are left-handed. We have a total. What we're going to do is we're going to say, what's the chance of being multiple birth? The only way to do that is to be here. What's the chance of being multiple birth and left-handed? 0.0077. And then the total isn't 100%. The total is these 11%. So that's the chance of being left-handed. Okay. So like I said, I'm expecting a number higher than the 3.5% that I had before. Okay. So that's what I've got. So let's go ahead and answer the question. What's the probability that a randomly selected child born in the region is a child from a multiple births, given that they're left-handed? We're going to say there is a 6.8% chance a kid is from a multiple births if they are left-handed. And again, what I'm trying to point out here is that this is twice as likely as just being from multiple births. So if you're left-handed, your chance of being left-handed, if you're from multiple births, your chance of being left-handed has basically doubled.